Okay, so welcome everyone to this presentation on techniques for optimizing asset analytics. You'll probably be here in this presentation today because you've probably started creating asset analytics within your Pi system, but you're probably not sure if you're doing the right thing. So you've come here for some guidance. And hopefully by the end of this presentation, you will have some guidance into best practices of how to deploy asset analytics within your own environments. So just to give us an agenda here for this session, first of all, we're going to go through an asset analytics overview, just giving you a high-level overview of what asset analytics is within the Pi system. Then we're going to go deep into those best practices. We're going to look into how it is best for us to build expressions, also using event frames and capturing critical events, as well as backfilling and recalculations, and also the management of those asset analytics that we create. And finally, of course, just to wrap things up nicely, we're going to have a little summary to go through everything, because it may be a lot of information for us to take in. All right, so let's go ahead and get started with the overview of asset analytics. Who here is already familiar with asset analytics and is using it today? Yeah, I can see about half of you. Yeah? And who feels confident that they've built those analytics for best performance? Just one of you. Wow. You need to speak to that guy out there. All right. So what is asset analytics? For those of you who haven't started building out your asset analytics and are not familiar with asset analytics, well, asset analytics is a feature within the Pi system which allows you to build real-time calculations upon your process data. We have over 150 different functions available for you to use. And these range from simple mathematical functions all the way to more complex statistical functions such as linear regression and so on. So as I mentioned before, these are streaming calculations, but they can be triggered based on events. So an event could be one of the inputs for the calculation receiving a new value, then the calculation takes place. Or it could be clock-based, so scheduled based on a clock. So maybe every 30 minutes you want to see the daily production for your plant. Then the outputs of these analytics can be written out to Pi points, which allows the history of those analytics to be stored for further analysis later on, and trending, of course, as well. Also, within asset analytics, you have the ability to create event frames. We're going to talk a bit more about event frames later on, so I don't want to give it all to you right now. And you have the ability to do roll-up calculations, which is aggregations upon your data. So you can do things like site-by-site comparisons based on, for example, the yield of your plant or whatever it may be in your case. Once you have those event frames set up, which are just tracking your events within your process, you can do things like notifications with asset analytics, which is just notifying people within the organization who need to be notified when something is going out of tune in your process. Asset analytics supports templates. So in the last speech by Frank, you heard a lot about templatization within the asset framework. Well, asset analytics fully supports that. So all of your asset analytics that you build can be built upon templates within asset framework. We have the ability to backfill and manually recalculate calculations. So I'm going to talk a bit more about this later on. But basically, you have the ability to go ahead and look what the history looked like for a calculation which you set up today, for example. And it allows for the auto recalculation of for late arriving data or out of order data as well. So these are just some of the features of what is available to you within asset analytics. That's an overview. So I want to take you through a workflow. I typically work with a lot of our customers. I work as a systems engineer within OSIsoft. So I work with our customers to really just help them get the most out of the Pi system. And I always hold workshops with our customers. And I sit them down in a room, and we have multiple different people within that room. And one of the most important people to have in that room when you're looking to build asset analytics is a subject matter expert. Or you want his insight or her insight into the operation of that asset. So, for example, here we have an asset here, which is a feed water pump. And typically what I see our customers doing is they have that subject matter expert who helps build out the theory behind the calculations that need to be configured for that asset. Once you've got that calculation, which has been given to you by the subject matter expert, you can go ahead and test that analytic within the asset analytics. Once you test that, you can see how it compares, how the results compare. And you can go ahead and schedule that analytic once you're happy that it works as you expect. So this is the typical kind of process that you take. And during that testing phase just over there, which is on the screen, it's usually an iterative approach. So you may write it once, it may work as you expect, but then you can refine that calculation as many times as you want before you go ahead and schedule that analytic. Okay, so that's great. We've gone ahead, we've scheduled our analytic. It's now calculating in real time for us. But then what's more is we can build this asset analytic based upon a template for our feed water pumps. So what does that mean for us? If I now build that asset analytic onto my template, it means that, yes, I have multiple different feed water pumps across my fleet. And now I can actually propagate that asset analytic, or that calculation, across my entire fleet. So imagine this is an efficiency calculation, for example. I've now got that across my whole fleet for all of my different feed water pumps. And what's more is you have the ability to then backfill and recalculate across your whole fleet. So this is the typical workflow that I see our customers use. And if you're not doing this today, maybe it'll be good to start this today. So this is why you're in this talk, right? To learn more about how you can implement asset analytics. All right, so just to add a bit of context here. So asset analytics are configured within Pi System Explorer. And Pi System Explorer is the client tool for viewing your Pi Asset Framework and the data and information within there. And if we take a typical use case of creating an asset analytic, well, here is one here where I want to monitor and detect problems with my compressor before they become catastrophic. What you will typically do first when you want to build out an asset analytic is you will model things, the asset within AF. So you will create the asset along with its input attributes, right? So it may have a temperature, a pressure associated to that asset which you're creating. Then what you're going to do is create your analysis, and then you're going to map those outputs of the analysis to attributes of the asset. So you now have a holistic view of the asset with its inputs and also the outputs, which you're calculating based upon the asset analytic calculation you've defined. Here's another example here. You can see, once again, we've built in our context with the hierarchy on the far left-hand side there. And we are doing this to aggregate EV and solar production for our substations. Once again, we have our inputs coming from that asset hierarchy. It could come from the asset, could come from somewhere else within the hierarchy as well. But typically, it does always come from the asset itself. And again, we're going to map those to our analysis outputs, which then can be used in dashboards such as Pi Vision if you're using that today. So just to give a bit of context and a little bit of background to what we're doing here today, because I'm going to be giving a lot of best practices, it's good to know a little bit about the theory about how Pi Analysis Service actually works. So this is a typical architecture for the Pi Analysis Service. And what you can see here is we have our Pi Data Archive sitting on its own individual box, the Pi Asset Framework as well on its individual box, as well as the Pi Analysis Service. It is possible for you to have the Pi Analysis Service run on the same machine as the AF server as well. But for best practice and for production environments, this is a recommended way to go. So what happens when you start up the analysis service? Well, first of all, it loads up the analysis configuration, and that analysis configuration is stored within your asset framework server. So it talks to your asset framework server and loads up the analysis configuration. With that, it loads up the inputs and also the outputs for all of your calculations. Once it's defined those inputs and outputs for all of your calculations, it can then store that in a data cache, and this data cache is going to be continuously polling for data for the inputs directly from the Pi Data Archive. So what this means is once this data cache is in memory, and once you then start up this analytic, you can go and get your data directly from that data cache rather than going ahead and querying the data archive. So this helps a lot with the performance. So there you go. It's reading from the cache. You've got your inputs going directly in there. In the case where you've maybe written a very expensive analytic, what you might see happen is that you can't actually read all of that data from the cache. And in this case, you're actually going to go ahead and read that from the data source, which is the PyData archive. So you go directly to there, and you'll start reading data from the PyData archive. And this is, of course, a scenario which you want to try and prevent as much as you can. It's not as efficient as reading that data directly from the data cache, right? So let's have a look into some design trade-offs. Asset analytics is optimized for streaming analytics. I've mentioned that before. So it's streaming calculations. Real-time data calculations is what asset analytics is good for. It is good for the real-time calculation. Well, the real-time calculations take priority over recalculations. So there are two independent workers here. So recalculations and real-time data are completely separate, but the real-time data takes priority. It allows for easy configuration, so no programming is needed. So some of you may be just typical users who just want to be able to play around with the system, do a few simple calculations. That is what asset analytics empowers you to do. It gives you the ability to create these analytics based on these functions, and it's very intuitive and very simple to build these out. What is it not suitable for? Well, it's not suitable for executing queries across really large number of attributes, for example. So you've got loads of attributes within your asset hierarchy, and you want to do an analytic based upon all of those, maybe hundreds or thousands. It's not going to be best performant with that kind of analysis. If you're looking to extract large amounts of time series data, again, I'm going to speak a bit more about this, but this is not really what the asset analytics is really strong at in terms of doing that, and also ad hoc calculations as well. This is, again, something which asset analytics can do, but it's not what it's been built for, necessarily. So if you're looking to do one of these three different things here, we may have PySystem tools other than the asset analytics available for you to use to do those. OK, so let's get stuck into things, and let's go ahead with the best practices, right? That's what you're here for. No? Yeah? All right, so let's go. So let's start from the very beginning. So within asset analytics, you have the ability to create multiple different types of analytics. I've taken you through some of them. We have the ability to write expressions. We can also do what's known as event frames. You also have the ability to do SQC as well through asset analytics. Now let's take the use case where we're building out an expression with asset analytics. Well, the first best practice I can give you when you're doing such is that you should use variables. So variables allow you to have logical steps into how you build out your calculation. So you can see here as an example, I'm defining what my flow rate is, and it's got a definition there of if the pump status is on, so on and so on. That is what I define my flow rate to be. Why do I say use these variables? Well, if I define a variable, I can reuse that variable later on in one of the latter stages of my calculations. What does this enable me to do? Well, I talked about the data cache and how we're caching data. Once you've already performed the expression once, if you use the variable later on, you don't have to perform that expression again and again throughout your calculation. That means you're performing the expression once, and it applies wherever it needs to within the calculation. So if you're doing calculations today where you are not using variables and you're actually stating the expressions again and again throughout your calculation, today is the day it needs to stop. All right. OK. Next is, again, I'm talking about variables again. Variables are very important. I actually didn't know about this one until recently. Well, when you have a part of an expression which you're interested in, you can actually assign that to a variable. So you can create a variable based upon an expression which you have in your calculation. And this is simply done by right-clicking on the expression that you want to create into a variable and selecting Assign to Variable. Did anyone know about this before today? OK. Just Mike. Well, I didn't know about this as well, so we're all in the same boat here. But it's very powerful, and it allows you to then substitute that variable across the multiple different occurrences that it occurs in later on in your calculation. So once you assign to variable, it automatically does that substitution for you. The next one here is very important. So, I mean, I go onto customer sites sometimes, and they're like, Nathaniel, can you help me with this analytic? I've written it, but I don't think I've done it to its best justice. I don't think it's performing as I expect it to. And I get in there, I log into Asset Analytics, and I'm just like, what's going on here? I have no idea what they're doing, and they expect me to understand what they're doing. So the next one here is you always use comments when you're writing your asset analytics. Yes, writing comments is extremely easy to do. It's just done by using the /, and once you do that /, it enables you to then it grays out the text which you're going to write. So you enclose it with you use the /. So you can see there are just some examples. Right there, we've done one comment there, and again after an expression as well, you can actually write your comments as well. Okay? All right, so now moving on, we're still on our expressions. This is another really clever one as well. This one is the exit function, and this was just released in the latest release of Asset Analytics. Who here is using the latest release? Is anyone using this? Yeah? Okay, great. Yeah, so this one is readily available to you. If you're not using the latest release, think about upgrading to this, because this is really great, because you're allowed to use what is known as the exit function. So if you're looking to do some kind of data validation, trying to test data before you actually use it in your analytic, such as using the bad val function, you are able to exit the calculation prematurely before it has to go ahead and do subsequent different expressions if it's not necessary. So you're avoiding the need to go ahead and perform calculations which are not necessarily needed based upon the criteria which you set. So in this case, we're using it for data validation, and we're looking at the if bad val of the pump status, then exit the expression. Don't go ahead and calculate further. And this is going to improve the performance of your calculations because you're not evaluating those expressions where you don't need to. Next is the ability to historize data. So it is always a best recommendation from OSIsoft to actually historize the data which comes out of your analysis outputs into a PyPoint. And of course, this is for many reasons, mainly due to the fact that you're keeping a system of record of that data. You're able to then go back and compare and see how that data performed over time. But in saying that, it's not always necessary for you to output to a PyPoint. For example, if you've got a variable in your calculation which you're doing, and it's going to be used at a later stage in your analytic, you don't necessarily need to write it out to a PyPoint. You could just assign it to a variable and use that variable later on in the calculation rather than writing out to a PyPoint. So just use it with wisdom, all right? The next one here is, again, fairly new feature, which allows you to use asset analytics to work with multiple different values. So here we are able to retrieve and filter data in your calculations. So we're using the functions such as recorded values by count or recorded values to bring back an array of data. So it's looking at an array of data over a set time range, for example. So maybe over the last 8 hours, you want to find out how many values you had for your bearing temperature in your pump. This is going to bring back that array. And once you have that array of data, you can go ahead and do filtering upon that data to maybe filter out the bad values or filter out the values which don't lie within a set range which you define. So this is a great function to use if you're not using it today. Is anyone actually using this one today? Yeah? Great. It would be lovely to hear about how you're using it, so maybe after the talk, or you can tell us about how you're using it, right? That would be great. Oh. All right, so next up is templates. I did mention about templates before and how we could use it, but basically templates provide manageability, consistency, and governance. So if you're using templates within AF, that's what it's going to give to you. And if you're applying your asset analytics to a template, you're going to get just that as well. So we use templates for repetitive work and things that are not easy. Well, maybe you're looking to roll out your analytic across multiple different assets. These are the use cases of when you would use a template. The great thing about templates is once you define a template and you build an analytic onto that template, and you're calculating, for example, the efficiency of a pump, yes, you only need to make a change in one place if you want to change that calculation. It doesn't mean you have different pumps which have different calculations for efficiency. You have one standardized version of the truth for that analytic, and you can go ahead and make your modifications to it as you need. Using templates for asset analytics allows you to be able to search and filter for your calculations and analytics very easily, and it's done within the user interface in PySystem Explorer. It's just very easy to then just search for analytics based upon a set template. And it's more performant as well, as a side note. Okay, this next one is one which I believe all of you should have tried. If you haven't, you can go ahead and try it after today. And this is being able to evaluate your analytics before you go ahead and schedule them. So this enables you to be able to see how your calculation is going to work. And it gives you that snapshot value based upon when you evaluate your analytic. So here is an example. You can see we've selected evaluate, and it's given us the values at the time of evaluation. Evaluate is just at the top right there, if you're not familiar with the evaluate button. And what's also useful is it also tells you the amount of time it takes for that analytic to take place. So you can get an idea of the performance of that analysis which you're writing. Is it performing too slow? Should you make modifications to it before you go ahead and actually schedule that analysis? The next one is, again, really useful. If you're not doing this today, I recommend that you go ahead and start using it from today onwards. So if you've done your analysis, you've evaluated your analysis, everything adds up, it looks right, but you may actually want to know, how does that analysis perform over time? Did it work 1 year ago as well? Well, you can go ahead and just test that analysis by doing what is known as a preview. So you can actually preview the calculation over a set time period which you're interested in. So you just define the start time and the end time, and it's going to go ahead and use the inputs to calculate all the outputs over that period of time which you're interested in. So this now allows you to see how the analysis is going to perform once you backfill data. So I get customers come to me and they're like, oh, the backfilling, I do it, and it actually doesn't work how I expected it to, and I end up having to delete the data and try again. Well, first of all, come here and preview your calculation before you do your backfill. So that's the advice there. A nice little thing there as well is you can see where the arrow is pointing. It's alerting us of some metrics. In this case, it's a metric which is in red, and it's just pretty much showing us that basically the time it takes for the evaluation of that analytic to take place is longer than probably the frequency at which we're trying to execute that analysis. So we may need to think about how we're actually going to schedule the analysis to ensure we allow it to fully compute before we go ahead and trigger the analytic to take place. And now just a word on expensive functions. So another common thing which customers come to me with is the fact that they are writing calculations and they're saying that it's not performing as they expect it to. Well, one of the main reasons for this is because these are expensive functions which you're using. And what are expensive functions? Well, an example of an expensive function is tag average. A lot of you may use that today. These functions are kind of getting a summary of your data. It's looking into a defined time period which you're interested in. Some of you choose a year period, for example, or a month, for example, and you're trying to find the average over that period of time. Well, these calculations are really dependent on the data which you have. So if you have very high frequency data or very dense data, there's going to be more that you're going to have to evaluate. So you need to be very careful in terms of how you schedule these analyses to run. So if you're doing a yearly average and you're calculating that yearly average every 1 minute, of course, you're going to run down into issues down the line. So what you need to be thoughtful of is, are you scheduling your analysis in order to get the best performance? Is it really necessary for you to perform that yearly average on a minute basis? Or could you do it every day, every month, or so on? So it's, again, just a way of just taking a step back and thinking about the way you're doing things and if it really does make sense. Okay, so yeah, there we go. The second point there is just all about, optimizations, as I was just speaking about. You can make smaller time ranges or evaluate less often. The last one there is just a word on compression. So is anyone familiar with compression here or not familiar? Does anyone know compression? Are you using it today? Yeah? Okay, so compression is really just an algorithm which is placed upon your time series data when it comes into the PyData archive. And it just allows you to kind of neglect values which are not of interest. Maybe not enough change has happened for it to be stored within the PyData archive. So if you apply compression, you're allowing less data to be stored for those Pi points, and therefore you can gain more out of it when it comes to doing the analysis in terms of performance. All right, so a word on event frames. Event frames are really just specific segments of time which you should be interested in your process. For example, maybe it's a pump which has just been started up. You want to see how your parameters are operating over that time period, right? So an event frame has a start time and an end time. And within this end time, you can monitor those parameters. So these event frames can be then used in reports or to allow you to do comparisons against these different event frames and also do some form of tracking as well. So the thing here as well is it allows you to capture data points at the close of the event frame. So you can see how data points have been behaving. So for example, if you look at the image at the bottom there, you can see we have a trigger to start the event frame, and we also have an end trigger as well to end the event frame. And we also have an output at close output, which is really just going to write out a value which we want to see once the event frame closes. So in this case, it is the tag average for the flow rate. Over the period of the event frame, we want to see that written as a value once the event frame closes. So even for me, this was a new feature which I didn't know about, that you can write out to outputs, which is quite shameful. But I'm sure some of you are using that today. That's a nice little feature there. So just going one step further from event frames is you have the ability to set up notifications. And notifications is really just notifying when those event frames take place. So you have notification rules which are based upon those event frame templates and with those start triggers and end triggers. And you're notifying the person responsible when they need to know. This can be done through an email as well as many other delivery methods. Within an email, you can have information, contextual information about the asset which the event has been created for, as well as links, hyperlinks to PyVision to gain more detail. All right, so now a word on management of your analysis. So if you use PySystem Explorer today, you'll be able to use the management plugin, which is just at the far bottom. And it allows you to go ahead and search for your analytics, which you build by the templates, as we mentioned earlier on. So you can see over on the far left-hand side, we have a search which we've performed, and these are all user-specific. So if you log into PySystem Explorer, you perform some searches. These are going to be saved under your own individual user. Once you've got that saved there, you can go ahead and see all the different analysis based upon that template, for example. It doesn't have to be filtered just by template. You can filter by name. You can use your wildcards that you're all familiar with when it comes to searching for Pi tags and so on. Or you could also filter by categories as well, if you're using categories for your analysis. Over on the far right-hand side, we have operations which you can do. So you can enable those analytics which you have searched for in your filter there. You can also disable them as well. And you can also do things like backfilling and recalculation upon all of them in bulk. So you no longer need to go ahead and find the individual analysis which you're interested in. Just find all of them and apply it in bulk. OK, so once you've gone ahead, you found your analysis which you're interested in, you want to do some management, you may want to do things such as recalculation or backfilling. OK? So just to be clear here, when we speak about backfilling, we're talking about going back in the history of a Pi point, and we're filling in the gaps of data which don't exist. when we're doing recalculation, it's typically a case where we have maybe modified our calculation to optimize it, and maybe we want to go ahead and write back to the history of the pi point. So in this case, we want to delete the information or data from before and now write new data to the pi point. So that's when you would use the recalculation. And again, there's just a notes there which is saying the real time versus the recalculations. These are two separate workers, recalculation and real time. And once you recalculate these analyses, another great thing is you're enabled to actually recalculate based upon your dependent analysis. So if you have dependent analyses, you can actually go ahead and recalculate those dependent analyses as well. Okay, and auto-recalculation just allows you to auto-recalculate when you receive out-of-order data, for example. And this can be enabled when out-of-order data is expected, so you can enable it then, or if, for example, if you require to recalculate past data. This is when you would use auto-recalculation. So don't enable auto-recalculation when past data shouldn't be modified. This is not when you would like to use this feature, or when the past data from dependent calculations shouldn't be modified. So just a note here on change management when it comes to writing out your analytics. Well, when you're doing these kind of things, it's always good to have your different environments. So if you've got a dev, a test environment, it's best to actually test out the analytics which you're creating there first and experiment before going ahead and moving to your production. This is always the best practice, of course. And it allows for experimentation, and it ensures that you may have many engineers working, building these analytics. You don't want anyone overwriting or changing work, which is very important for your production. So do the work in your test and dev environments first, and then migrate over to your production environments. And just a note here on high availability. So if you are a large enterprise customer and you are using the Pi system, we recommend high availability for the analysis service, and that can be supported but used in Windows Server failover clustering. So we recommend doing that. It's just known as high availability, or HA. We can provide more information for you on that if you need. And just lastly there, with high availability, we also, well, not with high availability, but another little point there which is important is buffering. So when you're writing out these outputs to the Pi data archive, it is great to use buffering, which is going to just buffer the data if the connection to your Pi data archive is interrupted. So it'll be just buffered and stored temporarily until the connection is restored. So use the buffer subsystem when writing out to your Pi points using the analysis service. So if you're looking to go further from this talk today, you can go ahead and look into more resources. Of course, we have another great talk coming up here by Zahab, I believe it is, on incorporating event frames into your operations, which is up next, and also Pi Square. There's a lot of information on Pi Square, which is around best practices for your asset analytics. There's actually one blog post which is posted by one of my great friends here called Sebastian. So you can go ahead and search for him on Pi Square. He's written a series which is really exploring different ways which you can optimize your asset analytics. So go ahead and search for that on Pi Square. Oops. All right, so just to summarize everything that we've seen today, it's been a lot of information. First of all, the first thing I said was that we have to use variables. If we want to start being efficient and performant in the way that we do things, we want to use variables to improve the performance of our asset analytics. Second was the use of comments. Don't ostracize other people from being able to see what is available to them or what data they're receiving based on the analytic. Make that data available, make that information readable for everybody so everyone in the enterprise can understand what's going on. Thirdly, we want to be able to exit functions, so we're not we're not performing expressions again and again, which are not necessary. And also, we want to save analysis outputs to Pi points where we can and where it's necessary to. We also wanted to build analytics based upon a template, which is more efficient and it's easier to manage. And also, we want to avoid expensive, frequently evaluated queries using summary functions such as tag average. So that's just a quick little summary of what we went through today. And with that, those are my contact details if you would like to learn more about best practices on asset analytics. You can't fit it all into a 30-minute speech here. And if you have any questions, feel free to ask. And remember, if you've got the app, go ahead and vote ahead if you like the presentation. If you didn't like the presentation, also vote. And if you didn't care, vote as well. Thank you.
Good morning. Thanks for that. John Kitching. Has this effectively replaced calculated tags? And if not, where do you see the cutoff between a calculated tag and analytics?
So when you say calculated tags, are you referring to performance equations?
Yes,
Yeah,
sorry.
right.
I'm
Okay.
old school.
Okay, so asset analytics, again, I mean, it's built for real-time data. It's not going to have some of the functionalities which you may have been able to do in performance equations before. But I don't know.
I think,
how would you?
so for the most part, I would say it's replaced performance equations. So it's more efficient. We want people to take advantage of the asset hierarchy, and obviously performance equations doesn't use that functionality. Some of the things you can do in like totalizer and such like hasn't been translated across to performance equations. We've been having conversations around our batch users and things like that as well. So some of the things are not there, but for 99% of the functionality, it can be done in asset framework, and I'd recommend you do it in asset analytics.
Okay, thanks for that. I was just thinking more about the overhead, really. If you're on 2 servers, whereas obviously a calculated tag is based on the archive server. So
Yeah.
that was my worry.
If you follow these best practices, then there's a lot of scope for doing lots of calculations with these systems. I've got customers that got up to 2 million tags on their data archive, and they're doing the asset analytics across that kind of stuff. There is processes to go through and make sure those asset analytics are running effectively so that you do actually get the most performance out of that system. We can help with that kind of tuning, and tech support can help you go through looking at tag lag and things like that, which calculations to take out the most out of the system, and how do we optimize those and make best use of it.
Cool. Thank you very much.
Any other questions? Yes. Okay.
Hello, Ladislav Čech, Unipetrol. I have 2 questions about the exit function. The exit function finished only the exact expression or all next other expressions?
No, so it exits as soon as it evaluates.
Exit function, it finished the expression.
Yes.
The calculation of the, and
Yeah.
it's finished only the exact expression,
that's right,
or
yeah.
all other expressions?
Just the exit, the exit function.
So if you remember the expression that was there was if the value is bad, then exit. It will actually exit that point. It will even do the then, else that entire analytic will now stop executing until it's rescheduled to run again, and then it will come through and reevaluate that. That's why we have the no output at the end of that expression, because if we want to continue on, we need that expression to complete.
Yeah.
Okay.
And the second question?
Yes.
I'm not sure if it's true. I have heard that PyAce will not support it in the future, and if do you plan that in PyF analysis will possible to create loops? Because until now I think it's not possible.
That's right. So PyAce, for those that don't know, is an environment where you can build .NET framework applications with proper programming like C# or VB.NET. We'll continue to support that application as long as there's an operating system that Microsoft provide that we can install that application on. So as far as we're concerned, it's still under support. You can still use it. The big thing with PyAce is there's so much that you can do with it because it's just an entire programming platform. Having everything that PyAce can do replaced in AF is just not possible. So we're exploring different methods of solving different problems. So we will have future methods to do things like looping and stuff like that, but it may be outside of the asset analytics. There's no plans I'm aware of at the moment to put looping into asset analytics. Okay. Answer your question?
Yes.
Okay. Any other questions? Make me run over there.
Oh, I had to run around yesterday.
I know.
Get my own back.
If you want to ask questions, sit at the front.
Dave Nunn. I had a question about backfilling.
Yes.
So if you create a new calculation and you've created an output pi point for that calculation, at the time you created the calculation, you then want to backfill it for a year. Are there problems with the pi data archive? Because obviously the pi tag doesn't exist in previous archives within the pi system. So are there limitations to doing backfilling when you're creating a new calculation if the tag didn't exist previously?
No, as long as you have the archive file for that.
So if you're running Pi Data Archive 2012 onwards, it will create the record in the archive for you, allow you to backfill without having to do any work. Prior to that, then you had to create the archives, or if the archives existed, you had to reprocess them to make it aware of that record. So if you're running the latest software, it's not a concern.
Even if it's even if you're running fixed size archives, is that still an issue? Or?
Yeah, it will just create the archives it needs.
Oh, okay.
Yeah.
Thank you.
Okay. Any other questions? Oh no.
You forgot the microphone.
I would help you, but I'm comfortable here.
Yeah, you were doing this yesterday. So.
Yeah.
Where were you? Oh.
Hello, it's Thomas Reiterer from RHI Magnesita. I have a question to the expensive expressions.
Yes.
You said if the formula is too extensive, yeah,
Yes.
is it only influencing the performance of this analytics or of all analytics? Can an expensive expression lower the total amount of our performance of our analytics?
Yeah,
Yes.
so if you're doing an expensive expression, the method that Nathaniel showed about showing the time that it takes to evaluate, you're able to identify which ones are bad and which ones are good. It will affect the analytic itself, but if you're in the situation where it's taking more time to calculate that and it's actually rolling over itself, then you might actually impact your other analytics as well. So you just need to be careful about scheduling and such like. If you're doing expensive things, like if I want to do an average over a month, if you break it down into smaller calculations that you do every day and then average that smaller calculation over a month, you can do tricks like that to help improve performance.
Thank you.
Okay. I think there's a question behind you.
Making it too easy for him.
Thank you. I have quite the same question about using tag average. Do you recommend using like value retrieval methods and get the average from that instead of using tag average?
I would use the tag average function. Just make sure that you're mindful of how many events you're going to pull back in. Use those compression algorithms to help optimize the data so that you're not storing repeated values that are the same that it needs to pull out of the system to average. So it's a combination between good management of that data archive, making sure the data is being stored properly, and then mindfully using those functions.
Yeah, thank you.
Any other questions? If not, round of applause for Nathaniel, please.
Thank you.